Right, we're going to go back to binomial a little bit, and we're going to do the binomial functions in Excel. So you need to get Excel running. And the first one we're going to do, n is equal to 8 tries, 3 successes with a 0.4 probability. And it's binom.dist. And there's also a binom.dist.range. And we'll do that one too. That one, instead of doing more or less, it's between two values. But this one, we have 3 successes. So the number S. And if you do this wrong, put in the wrong numbers, it'll just say you're wrong. You can't screw it up. So 3 successes, 8 trials with a 0.4 probability, and we want individual. This is exactly 3 successes. It's not cumulative, so it gets a 0. And the probability is 0.2787. Right, if you look in My Open Math, on the My Open Math page, there's a table of binomial probabilities. This is the way we used to do it. You couldn't look it up in Excel. You had to use a table. And across the top of the table are the probabilities, particular values. In Excel, we can do any probability, 0.327 if you want. But in the tables, they were restricted. So if you look at 0.4 on the table here, here's 0.4 probability. Down toward the bottom, and it's going to scroll off the screen here for the top, here is 8 throws with 3 successes. If you come across, you get to 0.2787. Right. Each one of these things is the individual probability of success. 0 successes, 1, 2, 3, 4, 5, and 6. So that's what individual means. Exactly that many. And you'll never see this again. Don't look at it. This is just useful for some things to illustrate, but it's not particularly useful for calculation. if we do, let's do it, all the individual ones, just like in the table, pick a spot. We want 0, 1, 2, 3, 4, 5, 6. We're going to have 6 trials, and this is the number of successes for each one, with a probability of 0.8. So equals binom dot dist. And if you forget a command, go to the help or look online, say, how do I do binomial in Excel? And it'll give you all the explanation you need. So you don't have to remember any of these commands. But I'm going to do it with a cell reference. So this is the number of successes. The number S is in D3, comma, just going to use 6 trials, 0.8 probability. And I want individual. And when I copy this down, I get the individual probability. I've got a chance of success of 0.8, so my chance of getting 0 successes is really, really small. The more chance you have of success, the more the distribution is shifted to the right. Mark all of those. We're going to make a histogram for it using the insert and bar chart. And we're just making a column chart. And this is what that looks like. It's got very low probability for 0 and so forth. I'm going to take the title out. And I'm going to change the x-axis using the select data. Go to select data, right-click inside the graph, select data, and all graphs are the same for select data. And over here on the edit, we've done this before, we're going to change the x-axis category labels. And I'm going to put in the number of successes. Right now, it's just got 1, 2, 3, 4, 5. We want the number of successes. In this, we're going to put a x-axis and a y-axis label on it. And if you click in the graph, right-click, we don't want to do that. That's not going to work. We want to make sure chart design is marked. If you right-click in here, you'll get chart design at the top. And on the far left at the top is add chart element. And we're going to add a axis title, primary horizontal title, and you can call it anything you want. Number of successes, and I need to take out the stuff that doesn't need to be there. And just as an aside, anytime you do something that you might need to remember, label the crap out of it. Everything you can put on it that helps you remember it. Then back to add chart element. I lost my chart design. Click in it, go to chart design, add chart element, axis title. This time we want the vertical axis. And this is probability. That's what it looks like with 0.8 successes. I'm going to change this view back to 100% because I'm going to put more stuff on here. Hopefully you've got your own, you can see it on your screen. This is 0.8, and I'm going to do 0.2 probability. Right here, I'm going to do equals binom.dist. This is the number of successes, comma, 6 trials with a 0.2 probability. And it's individual, has 0. And then copy that down. And this one is just that one turned upside down. You got it? Oh, okay. What happened? Oh, okay. Yeah. Oh, what's the matter with it?
It says hashtag now, so I don't know what I did wrong.
Oh, you gotta.
And you already this number, so I have to
Yeah. Doesn't excuse me, my bifocals don't do that. Oh, it does. That's a O there. B-I-N-O, not 0. Okay, cell reference first. Over. One more. There you got it.
Yep.
6. 0.2 and 0. There it is. Then put it down, and it'll give you that. And if I make a histogram with this one, insert bar chart, it is this one turned the other way. That's not the same, is it? What am I missing? I did something wrong. Which one's wrong? 5. 6. Oh, I got to have one more. And then this has got to be different. Those are mirror images of each other. If I want the probability of 3 or less in the 0.8, I have to add 3, 2, 1, and 0. That's what the cumulative is. So for something to be less than, it's the probability of 0, 1, 2, and 3 added together. If I want the probability of more than 3, I have to use 1 minus the probability of less than or equal to 3. I have to use the complement. There's no command in the binomial to get the upper end. You have to get the lower end and subtract it from 1. Right, and all the distribution functions in Excel start at the left. Anything cumulative starts here, and if we want something on the other end, we have to subtract it from 1. That's the binomial, or excuse me, the only discrete distribution we've got, and it is the ultimate in discrete. It is 1 or 0, this or that. All the others we do are continuous. And a continuous distribution is all space, like a normal distribution, there's no pieces in it. It's continuous, it's got a middle, the average, and it goes in both directions. It literally goes to infinity. Minus infinity and plus infinity. So there's no divisions in it. And the simplest one that is continuous is a uniform distribution. There is no probability that's greater than the other. Every probability in here is the same. The height of the curve indicates the probability. If this one goes to 30, starts at 0 and goes to 30, then the height of this curve, the probability of every event, is 1 over 30. In the normal, it's going to be toward the middle is more probable than toward the ends, but the uniform demonstrates everything about it that you need. If we want the probability of less than 20, the individual probability of 20 in a continuous distribution is basically 0. So probability of less than 20 is 20 over 30. Probability of less than 15 is 15 out of 30. And the probability between 20 and 30 in here is 20 over 30 minus 15 over 30. The normal is different only in that the probabilities change as we go up and down. In the normal, the probabilities, this is the average, and the probability that something is less than the average is 1/2. The mean, the median, and the mode are all at the same place, the average. So the average is literally the most probable number. And that's why it's the average. It is simply the most probable. The average plus one standard deviation and the average minus one standard deviation. The probability that a value is in here is 0.68, 68%. Average plus 2 standard deviations, average minus 2 standard deviations. That's a 95% bet. And I can break it up into pieces. I can get this probability in here. I can get the probability from there to there. Anything I want using those pieces. This is elephant birth weights. And in case you're wondering, I have no clue what an elephant birth weight is. This is entirely made up. The elephant birth weight, the average is 100 kilograms and the standard deviation is 20 kilograms. And I'm going to make a normal distribution for this. The middle is 100. One standard deviation up is 120. 2 standard deviations up is 140. 1 down is 80. 2 down is 60. The probability that an elephant at birth weighs between 60 and 140 is 95%. What's the chance that the elephant birth weight is greater than 140 or less than 60? 95 in the middle. How much is outside? 2.5. What's the chance that the elephant at birth weighs between 60 and 80 kilograms? You only need the pieces. Here's 68. What's in this chunk right here? 95 overall, 68 in the middle. What's the difference? 27. This and this are 27%. What's in one piece of it? Half of 27 is 13 and a half. 13 and a half in here. The chance that the elephant birth weight is between 60 and 120 is going to be 13 and a half plus 68. Add those together and I have the probability between 60 and 120. All of these things are calculated this way. You remember the z-score. Everything in statistics is measured in standard deviations. So that 60 is 2 standard deviations below the average. 80 is 1 standard deviation below. The z-score is how many standard deviations. X minus the average divided by the standard deviation. The deal with this is I can put anything I can claim as a normal distribution on the same basis. If I have the length of salamanders and a mean and a standard deviation, I can put it on a -2, -1, 0, 1, and 2 basis and make all the same bets. So a z-score is a standardized score. So 60 minus 100 divided by 20 is -2 standard deviations. 80 is -1 standard deviation. All distances in statistics are measured in standard deviations. That's why the standard deviation is important. So once I have a z-score, I can put everything on the same basis. This is the way it's written. Normal distribution with a mean of 100 and a standard deviation of 20. When it's standardized, it's a mean of 0 and a standard deviation of 1. 2 down, 2 up, 95%. 60 and 140, or 2 and -2. That's normal distribution probability, and all the bets that are made in a normal distribution basically are this. The particular probabilities, go to Excel. Everything in an Excel function for probability comes from the left. So I'm going to get the probability that an elephant weight is less than 60. What did I tell you the probability was in the empirical rule? Less than 60. Two and a half. Remember, 2.5, 68, and 95. If I put in 60 here for my normal probability, this is equals norm dot dist. Put in equals norm dot dist, and it says what it's going to do. Returns the normal distribution for the specified mean and standard deviation. Parentheses. There's the x value. I want to know 60. The mean is 100. The standard deviation is 20. And in this one, there is no practical use for an individual probability. All the individual probability will give you, if you put a 0 in, is the height of the curve, which is not a probability, it's just the height of the curve. It is a probability, but it's basically 0 because it's a continuous distribution. Always use a 1 for the normal distribution probability. And the probability of a value less than 60 coming from the left is actually 0.023. What did I tell you it was? 60 is really 2.3%, not 2.5%. This, though, is the probability from the left up to 60. All the probabilities will be from the left. In this picture, we've got 95, 68, we got it all spread out. Both sides, everything. The only probability you will get from a norm.dist is from the left. If I want 80, this was 60, I do 80. What should be the probability to the left of 80? Look at the picture. What's the probability to the left of 80? I've got 13.5 and 2.5. It should be 16%, 0.16. This is equals norm.dist. And you can just pick it off the list, double click it. I want 80, 100, 20 standard deviation, and it's always cumulative. It's cumulative from the left. And the actual probability is 0.158, 15.8%, not 16. So the empirical rule is within 2 decimals, basically, of the actual probabilities. How about if I put in 100? What will I get out of this command? The area to the left of 100 equals norm.dist 100, 100, 20, cumulative 1, 50%. The empirical rule gives you chunks. The command in Excel gives you pieces, always from the left. 120 and 140 equals norm.dist. And this time I'm going to put in the cell reference, D36 for me, comma 100, comma 20, and cumulative 1. The area to the left of 120 is 84%. If you go back to the empirical rule, the area to the left of 120 is 68 plus 16, which is 84. And the actual value is 84.1. 0.841 of the area, or 84.1%. The total area under any probability curve is 1. What if I want the probability of a number greater than 120? Subtract it from 1. 0.1 minus 0.84. The command only gives you probability from the left. The probability to the left of 140 is 0.977. And if you look at the picture, it's 2.5 greater than 140. And this is basically 97.5. If I want to know what is to the left of 130, it's equals norm.dist, and I'll just use a cell reference, 130, comma, 100, comma, 20, comma, 1. What should it be, approximately? Before you calculate any probability exactly, look at the picture. What should it be, approximately? Here's 130, right there. 68 plus 16 is 84, but less than 95 or something like that. Don't ever calculate one without drawing the picture and looking at the possibilities. And the probability is 0.933. 93.3% of the distribution is to the left. 1 minus that is to the right. All the probabilities in Excel come from the left. If you want anything else, you have to subtract it. I have fruit, why not, that weighs 517 grams with a standard deviation of 8 grams. How big is the standard deviation compared to the average? You remember the coefficient of variation. In the 120, I had a standard deviation of 20 and a average of 100. That's 20%. The standard deviation is 20% of the average. Here, 8 over 517. This is much tighter distribution. I want the probability that I have between 507 to 509. This is a very narrow range. Here's the picture. 517. If I go up one standard deviation, 517 plus 8 is 525. Up another 8 is 533. Down minus 8, 509. And down again is 501. So I want this range right here, 507 to 509. I have to do it in two pieces. Equals norm.dist. What's to the left of 507? 507, comma, 517. I say that was the average. What's the area to the left of 507? $10.6, 0.106, 10.6%. What's to the left of 509? Equals norm.dist. $509. 0.158. What's the area between them? So the probability of a number between 507 and 509 is 5.3%, or 0.053. 5.3% of the area of the distribution is between those values. If I wanted bigger than 509, I would have to subtract 0.158 from 1. That gives me the upper end. All of these areas come from the left. Anything else you need, if you want this side, you have to subtract it from 1. What's the chance that something isn't between 507 and 509? I got 0.05 in that little interval. 1 minus that gives me the rest of it. That's how these things work. And the empirical rule gives you pieces, chunks. The function in Excel always comes from the left. It's the only thing you need to remember. And we can use any value we want in the norm.dist. Pick a spot, do equals NORM. What else is in that list of commands? Right below the norm.dist is norm.inv. This is the inverse. What does the command want for the inverse? What's the first thing it asks for? It wants a probability, and then a mean and a standard deviation. Instead of getting a number and then finding the area to the left, we have the area to the left, and it will give us the number. So if you put in 0.4, and let's go back to elephants, 120. This says that 94 cuts off 40% to the left. Those are the only two norm commands you need, norm.dist and norm.inv. Dist gives you a number, or you give it a number, and it gives you an area. .inv, you start with an area, and it gives you a number that cuts that off to the left.